today's session, I'm going to teach exponential smoothing. It is one of the method of time series, which refers to you can say quantitative method. So under this method, it is based on the assumption that the period would be t, that is t stands for time period, and the learners and the researcher need to calculate the forecast for the last period, which denotes symbolically ft minus 1, and of course the actual demand of the last period that stands symbolically a t minus 1 will be given. So this method that is called under the method that is called a smoothing exponential smoothing method, where the alpha expresses how much the forecast is react to the observed differences between the future forecast and the actual present forecast. If the alpha value is low, there is a chances of little differences and their particular reaction. If the alpha is high, there is a lot of or plenty of reactions to their differences. So that's it's all about the exponential smoothing, where it shows how to estimate the forecasting values of the particular scenario relevant to the actual period of symbolically, that is at minus 1. So let's come up with the question or example that is given in this on the screen. It is given the bottle water at Kroger, where the alpha value is already given in the question, that is zero point 0.2. Actual values and the number of months is already given in the question, and the forecasted value of the first month will also given in the question, and you need to estimate the rest of the forecasted values based on the actual values. So in the January month, the actual values or the actual value of a particular period, that is January, is given 1325, and its forecasting value is also given 1370. Now now in the question you need to calculate the actual value based on the forecasted value. It means you need to calculate the forecasted value of the July month. So this is a question given to you where the number of months is to be given, the actual values is to be given, forecasted value of the first month is to be given, and the rest of the forecasted value is need to estimate, is need to calculate, and that is all about this question. So how to calculate? It is based on the following formula, that is ft is equal to ft minus 1, that is forecasting value of the last period, plus alpha value, which is already given in the question, at minus 1, that is the actual value of the last period, minus ft minus 1, again it's the forecasted value of the last period. So it is given in the last period, January. So the actual value is 1325 and the forecasted value is 1370. Now we need to calculate the forecasted value of February month. So how to calculate? This is given the forecasted value. You need to calculate first alpha. Alpha is already given zero point 0.2. Actual value is 137325 minus, that is 1370, and then you multiply with the alpha. So once you get the difference, it is 1325 and 1375. So automatically the answer is for 45, and once you for the 45, the minus 45 and the alpha is zero point 0.2, just multiply 45 into alpha 0.2, you will get the 9. There is a value that estimated is 9. So once the 9 has been estimated, just subtract from the forecasted value of the January, that is 1370 minus 9. So you will get the forecasted value based on the actual value of the February month, that is 1361. Now come up from the March, how to estimate the forecasted value of March month. The value is you need to estimate of over the last period. So what is the difference? 1353 minus 1361. So whatever the value, let's say the value would come up around 8. The value is minus 8 into alpha value is zero point 0.2, minus 8 into zero point 0.2. So you will get 4. You will get not 4, it's 2. So you have to deduct the forecasted value of the last month, that is 1361 minus 2. So you will get 1359, the forecasted value of the March month. I repeat once again that you need to estimate the forecasted value of the March month. That means you have to follow up the actual and forecasted value of the last month, that is February. So one actual value is 1353 minus forecasted value is 1361. What is the difference? The difference is 8. So the difference is 8. So just multiply it into zero point 0.2. You will get the value is 2. So just deduct the forecast, just deduct the 2 from the forecasted value of the February month. Then and later on you will get the forecasted value of the March month. That is 1361 minus 2. You will get the 1359. So, in the above example, there's given a bottled water at Kroger, which is one of the famous company in USA. So the data has been given in the following way, that is the number of months, the actual values, and the forecasted value. In this question, the January month of actual and forecasted values is already given. And in this particular scenario, the actual values of all the months will be given, and you need to calculate the forecasted value of June month. So how you calculate the forecasted value of the June month? So this is a formula has been given to you. You need to calculate the forecasted value of the last period, that is the f t minus 1 plus alpha at minus 1 minus ft minus 1. So you need to calculate the forecasted values of all the months, and that's the question stands for. So in the January month, the actual and the forecasted value is already given to you, and the actual values of all the months from January to May is already given to you. Now you need to calculate the forecasted values of February to June month. But how to calculate? Only the values, actual values is already given to you, and the alpha value is zero point 0.2. So it's very easy to calculate the forecasted values of January to June month. How to calculate? Just by taking out the differences of the actual and forecast and just multiply into alpha value zero point 0.2, you will get the forecasted value of the next month. Then once you get the February value forecasted, then you can easily calculate in the month of March. So let's begin. In the month of January, the actual and forecasted value is given. Just you can say subtract these two values, 1325 minus 1370 into zero point 0.2. So what value you will get? You will get the value 9. So you will get the value of 9. Then what? How to calculate the forecasted? Just subtract the 9 value from the last period of forecasted value, that is 1370 minus 9. You will get 1361. So once you get the forecasted value of February month, now come up to the March month. You need to calculate the forecasted value of the March month. So obviously you need to subtract the two values that is actually and forecasted of the last month to calculate the forecasted value of March month. So 1353 minus 1361 into zero point 0.2, you will get the value that is 2. So once you get the value of 2, that means you need to subtract the forecast. You need to subtract the value of 2 from the forecasted value of February month. That is 1361 minus 2. You will get 1359, the forecasted value of the March month. Same, you have to apply the same follow up, same rule in the upcoming months. So in case of April, you need to calculate the forecasted value. Just subtract the actual and forecasted value of March month, multiply into a alpha value that is zero point 0.2. That means the value comes out to be 10. So 1359 minus 10, you will get the value that is 1349, the forecasted value of the April month. So now you need to calculate the forecasted value of the May month. Obviously, you need to subtract the actual and forecasted value of the April month. That is 1275 minus 1349 into zero point 0.2, that is alpha value is 0.2 into 0.2, which stands the rule over, which stands into the formula as well. So you will get the forecasted value. So the value which you have get it, that is 7. The 7 value is came out, then just deduct the 7 value from the forecasted value of April month, that is 1349 minus 7. You will get the forecasted value of May month, that is 1334. Now you need to calculate the forecasted value of the June month. So definitely, while calculating the forecasted value of the next month, that is June, then you have to follow up the actual and forecasted values to calculate the forecasted value of the June month. So 1210 minus 1334 into 0.2. That means you will get around 15 values. So just deduct the 15 value from the forecasted value of May month, that is 1334 minus 15. You will get the forecasted value of the June month, that is 1309. So this is a particular you can say procedure to calculate the forecasted values of all the months under exponential smoothing method. So this method is actually portray the difference between the actual and forecasted value with reference to the alpha value, which shows whether there should be a higher difference with their reactions or the lower difference with their reactions. So if you check out the forecasted values, there is a lower difference. As why there is a lower difference? Because the alpha value is low. If the alpha value is low, that is 0.2, that means there is a lower reactions to the differences of the forecasted value between all months or among all months. So that is the conclusion of this example. We'll come up to the next example, that is the alpha. The same example has been followed with a different alpha value, that is 0.8. So if you check out the alpha value is 0.8, if higher the alpha value, that means higher the reactions to the differences of the forecasted value of all months. So if you check out the same procedure to be follow up in the last question, and you need to apply the same procedure in this question as well. If you check out the forecasted value of all the months, there are huge differences. That means If the alpha value is high, then there is a higher differences or reaction to the differences of the forecasted value of all the months, that is January to June. So if you need, let's take an example, if you need to calculate the forecasted value of the February month, just make out the difference between the actual and forecasted value, multiply into zero point 0.8, whatever the value that you will get, just subtract the value of or forecasted value of the January month. So once you subtract the forecasted value of the January month, you will get the forecasted value of the February month. That is 1334. So if you look out, there is a huge difference. Why there is a huge difference between the forecasted value of January and February? Because the alpha value is high, and as a result there is a higher reactions to the differences of the forecasted values of all the months. So this is the same procedure to be followed in this question, and you need to calculate the forecasted value of February to June month. This is a you can see the graphical representation. So whatever the values of the actual and forecasted with reference to alpha value zero point 0.2 and alpha value zero point 0.8, which has been shown in the diagram. So if you look at the diagram or the dot points in the pink line, it's automatically declining, and when you see the yellow line, it's automatically first initially declines, then again initially up, then automatically it's decline frequently. Why it declines so much directly to the frequently at a decreasing rate? Because the alpha value is high. Why? The pink line, the trend line, it's not declining so frequently at a decreasing rate because the alpha value is low. When we talk about the actual values, it's already given because the actual value is same in both the questions, but with different alpha values. That is actual. If you see the diagram, it automatically first increase at an increasing rate, then remains constant, and immediately it declines at a decreasing rate. So this is the impact of the smoothing constant values. What is alpha is a constant values which has been given to judge the actual values, to find out the forecasting values of the last periods. So this is a summary of the moving averages. The advantage of moving average is very easy to understand. It's very easy to calculate. It's very stable to forecast of the particular different periods. Whether it would be two moving average, it would be five moving average period, it would be eight moving average period. So it is always be a stable results to come out while forecasting the future period based on the past period. So when we obviously every method has advantages and disadvantages as well. So when we talk about the disadvantages of moving average method, it requires a plenty of, you can say, a past information, and you can see infinite in periods always being used in moving average because it is an infinite series. When we talk about the moving averages, there is no limit actually while adopting this method. So there would be a plenty of past information or past data points automatically. If there is a finite series, so it will save the time for the researcher. So when we talk about the next disadvantage is lags behind the trend. Moving average never portray the exact trend lines, which always shows an inaccuracy because the trend line does moving at trend analysis doesn't suitable in case of moving average methods, and that's the main reason it is always a one of the disadvantage, as every method portray the trend analysis. If you see the exponential smoothing method, this This method is always show a trend analysis from increasing to decreasing, but moving average doesn't show any such trends. It ignores the complex relationships in data. So when we talk about the complex relationship, it's not dealing with one or two variables. It deals with more than four or five variables. But moving average doesn't follow such relationships in the data, and as a result, it is one of the limitation of the moving average method. Let's talk about the comparison of the moving average and the exponential smoothing method. So these are the similarities and these are the differences. Both methods are very appropriate when you talk about the stationary series. Stationary series when where plenty of the months has been given. If you talk plenty of the months has been given in the particular scenario, moving average the months, the time series time period has been follow up. In the exponential smoothing, time period is also follow up. Both methods depends on the single parameter, that is the time period. Both methods lag behind trends. That's true. That both methods, as I told, that moving average is lacking behind the trend, does not show an accuracy in the trend analysis. Same, the exponential shows a trend analysis, but not with accuracy level. Even none of the methods will show the accuracy behind that what exactly the expectations about the future scenario. In fact, if there are any errors to be found in these both methods, so automatically the error can be rectified, can be forecast by using this formula, that is alpha 2 by n plus 1, or n is equal to 2 minus alpha by alpha. So this is a formula. When someone has found the error, just use this formula. You can easily get the mistakes. You can easily get or identify the errors in the particular data. The differences between the two, the exponential smoothing carrying all the past data forever. Obviously, that moving average is relevant to the data which is given into the number into the period wise, but exponential smoothing is not related to the only the months data has been given, and of course it refers to all the future data always be forever. Moving average eliminates bad data after in period. So as I told, the exponential smoothing, it's not related to the good data, it's also related to the past data, it includes everything. But moving average always be eliminates bad data which has no use after a certain period of time. Moving average requires all n past data points to calculate the new forecast estimation. Of course, both methods equally require the past data point, that means past data, to calculate the new forecast values. But in fact, the exponential smoothing only requires the last forecast and the last observation of demand to continue. If you see that how I calculated the exponential smoothing, the forecasted values will be calculated based on the last period. So that's why there is a huge difference between the moving average. Moving average is requires the past data of number of months, that is the 3 months, 4 months, 5 months combinedly. But when we talk about the exponential smoothing, it's just only related to the last period. Between the moving average and the exponential smoothing, that exponential smoothing requires to calculate a new forecasted estimation based on the last period, not of the all the last periods, it's only the last period. But moving average requires the number of the last periods. So if you calculate the two moving average, you need the calculation, or the you need to calculate a new forecast estimation based on the last two periods. So this is a huge difference between the moving average and the exponential smoothing. Next, we talk about the trend analysis. This is one of the most important concept that how the trend is to be drawn and how it could be include the what kind of data it could be include in such analysis. So I let me tell you under the trend analysis, the exponential smoothing, a regular exponential smoothing, a regular past data of the relevant past periods will be included in the trend analysis. So, if we talk about the moving average or we talk about the exponential smoothing, so exponential smoothing will be adopted as compared to the moving average because exponential smoothing shows a trend analysis in the particular data. So if you check out the impact of trend, the actual and forecasted value, the actual value has been shown in the dot point and the forecasted value shown in the trend line. That's called the forecasted value. So when you accept the trend analysis, how you portray the actual data should be in the dots or in the points, but the forecasted values should be in the trend line. And that's the difference of moving average and why the moving average is not being accepted in the trend analysis. Only the exponential smoothing model will be accepted. That's true that it is necessary to include the trend analysis and exponential smoothing because it portray that what the data stands for during the actual and the forecasted period. Trend analysis, the long-term sweep or the journal direction of movements in a time series. So according to the time period, it shows how much the value, how much the future and the forecasted values will become changed during a particular period of time. So that's why it shows a long term sweep, whether it goes up and down, showing the directions of movements in a particular time series, whether it would be monthly or yearly. So it considers a non-stationary time series techniques as it refers to the last future period. So we can talk about the time series which related to the non-stationary that is very appropriate for the data which shows the upward and the downward trends. If you look out the diagram, it shows from the decreasing to increasing trend, and the forecasted value is also shows the increasing, then little bit and then automatically increasing trend. So this is a way that how the directions of movements will be shown in a particular time series scenario. Seasonality analysis, this is also the another concept. It always shows the adjustments, that how much the adjustments to be done in a time series data and how much the variations will be possible at the certain period. It always been adjusted with a seasonal index. What is the index? Is the ratios of average value to the overall average values. That's called the seasonal index. And how to calculate the seasonal index? That is a ratio. That means average value of of one item by overall average value of all the items. So that is called the seasonal index. So whatever the value has been given, like for example, actual demand of a particular product. So you just need to calculate the average value of all the items and the average value of one item. So that is called how to this is called the seasonal index, and how it would and seasonality analysis is really easily to adjust with seasonal index. It would be monthly basis, it would be days basis, it would be weekly basis, it would be yearly basis, it would be half yearly basis. It easily adjusts with all the time series. For example, demand for coal and fuel oil in winter months. So in the winter months, it would be three, it would be two, it would be four. Automatically, it will easily such analysis will easily adjust in such months, whether it would be summer months, it would be quarterly, it would be half yearly, it would be yearly as well. So it easily adjust, especially the trend analysis. Now, we talk about the linear regression. If we talk about the linear regression, what is regression? Regression portrays a relationship between the one or two variables, whether this particular two variables will easily have a positive or a smooth straight relationship or a negative relationship between them or not. And while studying the relationship in forecasting, there are the various mathematical formulas which has been shown. So the linear regression, it always portray a straight line that fit into a data. It explains the changes in one variable due to the changes of other variables. If there is a change in the other variables, or there is a change in the values of other variable, it automatically impact the change in that one variable or another variable. So dependent variable, there is a mathematical equation, dependent variable that say, for example, x, then independent variable, let's say y. So the equation would be the linear regression main equation would be ax is equal to a plus by. If dependent variable is y and the independent variable is x, that means y is equal to a plus b x. So this is the linear regression equation, the main equation to so that this particular equation will use to know whether the state line would be possible while using the data or not. So by using the linear equation, it always try to explore that which independent variables, whether it would be labor, it would be wages, or any other, it whether affect the dependent variable or not. Let's take an example. Do people drink more when it's cold? So automatically, which line is best fits the data, and that's called the linear regression. So this is a way we don't put up any lines. It's here. It always shows in the dot points. So alcohol sales would be the you can say y-axis, and the monthly temperature it would be that is cold, that what temperature during the winter seasons, that is the average monthly temperature. And this is a way that how it portrays the data in a based on the assumption. So now if we talk about the trend line, we can use up the trend line based on the follow of the data. This is a trend line which shows in the red line. So this is a green line which shows whether it is an independent to one variable is independent to another, or the another variable is independent from the last variable. So this lines is based on the assumption whether red or green. So there is a predicted line, that how the predicted line would be, which I already shown here. So the best way, or that this method, of course, it always observe like to minimize the error. And how to minimize the error, this is a mathematical equation. If we talk about the regression line, this is the main equation, that is y is equal to a plus bx, or x is equal to a plus by. But when we calculate the error, so and this is the error, that is yi, that is an observed value, and the y delta, that is a predicted value. So whatever the predicted and observed values will be there, just subtract or have just calculate the difference between the two. You will easily find out the error of the, or you can say, present data. So that is the and by the straight line. So why was the reason behind the straight line? If the red line is a predicted line, if the green line is a is the error line to which has been estimated. So why it have been estimated? Because to get if any errors to be find out, or if the data doesn't fit, so the errors we can easily find out using this formula, and while formula you can easily get the accurate trend line of the possible situation. So green is red is the error involved in the data. So once the researcher find out that there is an error in the data, then the formula would be used, and this is the error formula that how to calculate based on the observed value and the predicted value. So once being calculated, you can easily estimate the green line, which is called the error free line, and this line fits into a data, and that's called the regression linear line. Now we talk about the least square method of linear regression. The main purpose of the least square method is to minimize the sum of squared errors. So whatever the error has been estimated, just square it, and that's called the least square method of the linear regression. So whatever the error would become, it's zero point 0.2, the value of error that is zero point 0.2, just square it, you will get the least square methods of linear regression. So this is a value, this is the same example. What does it mean? So obviously the alcohol sales and average monthly temperature is measured on the x and y axis. So red line automatically is filled of errors. So why it has been shown, see it how it has been portrayed here. What was the mean? Why the least square method has been used? To just to find out the difference of the errors between the dot and the main trend line. So these are ones to find out the errors of the difference of the dot and the error trend line, that is the red shows in the red line, that is called the, that is the main reason to estimate or least square method. So least square, why it is least square? Because of these differences to find out, or due to minimize such differences, least square method is to be used to minimize the distance between the line and the particular points. So these are that how it portrayed into the box to have a close look up that the difference between the dot and the trend, how to reduce the distance between these points and the line, and that's called to apply a least square method of regression. Least square method of linear regression. So the main regression line that is called the y is equal to a plus bx, and there is another two that variables, or you can see the constant interslope, that is a and b. And how to calculate the value of a and b? Y bar minus bx bar. Y bar is the mean of y variable, is the mean of x variable. How to calculate the b variable is sigma xy minus n xy mean. What does xy mean? So once to calculate the xy, so once to divide into an average, divide into a number of items, you will get the xy bar. Then upon by sigma x square minus sigma x bar square. So whatever the mean has been calculated of variable x, just square it, and you will get the value of b. How we compare the forecasting models? We need, of course, we need any matrix that provides the estimation of accuracy. Obviously every method obviously involves some sort of errors, and that's called the forecast error. So this obviously when we compare the forecast error, there is another formula to calculate the forecast error, that the difference between the actual and the forecasted value, which is called the residual value. What is residual value? When you get the difference between the actual and forecasted values, you will get the forecast error. And why there is a need or need any comparison between the forecast models, that is the forecast error, and which provides the estimation of accuracy. So this is the estimation of error which provides a accuracy level between all the techniques, whether the qualitative and the quantitative techniques. So mainly such errors will be used so that no particular errors would be involved in the future. Errors can be based a consistent or error based on the random basis. So based if that if the researcher is having a consistent error in using or in the particular past data. So how you modify using this particular forecast error formula. Then the random error is like, for example, if you particular apply any method and randomly from initially you just by mistake you have an error or did an error in a particular for calculating the future forecast, or if you found any past error, use this formula. You can easily rectify that error and accordingly you can forecast about the future values. So this is a measuring accuracy. So these are the formulas has been given the errors if it found. So these are the formulas to be used. So these are the four common techniques: mean, absolute deviation, mean absolute percent error, mean square error, and root mean square error. So this is a formula which will be used. So So now we come up to the cost of production, that is unit 10 and under block 3. So let's begin the theory of costs. So basically, when we talk about the cost, then every seller it needs to produce the goods and services, or every firm has to produce the goods and services, of course, by using the various factors of production. But when the firm or the seller spend some amount on these factors of production, it would be land, labor, capital, technology, organization, or enterprise, that exactly called the cost of production. So if any firm spend a certain amount of money on these factors to produce a certain product or goods into a market, or to sell the goods to an ultimate consumers, that particular spending amount, it's called cost of production. Now we talk about the cost concepts, that is the opportunity cost and actual cost or concept, business cost and full cost, explicit or and implicit or imputed cost, out of pocket and book cost, fixed and variable cost, total, average, and marginal cost, short term and long term cost, incremental and sunk cost, historical and replacement cost, and private and social cost. So these are the costs which will going to learn one by one. So let's begin the opportunity cost and the actual cost. Opportunity cost refers to an expected return from the second best alternatives which has been foregone due to the scarcity of resources. It means while gaining one unit of labor, a particular researcher or a firm has to foregone the second best alternatives which have the shortage of resources, and that expected returns that get from the second best use of resources which have to be sacrificed due to the scarcity of resources or the shortage of resources, that's called the opportunity cost. Actual cost basically are those expenditures which has been done by the firm for the payment of labor, for any payments of materials, machinery, equipments, or any other resources. That's called the actual cost. So, what is the difference between the opportunity and actual cost? Opportunity cost are the expected returns that a particular firm will get from all those best alternatives which have a shortage of resources. That is need to be that resources need to be foregone due to the shortage of that particular resource. But actual costs are the payments which has been incurred for the or you can say the expenditure or the outlay which has been incurred by the firm for the payment of the various resources, whether it would be labor, material, machinery, equipment, etc. Let's talk about the business and full cost. When we talk about the business cost, so whatever the expenses or expenditure incurred into a business, that's called the business cost. So if we talk about the similarity of the business and actual cost, both are very similar because the actual cost are those expenditure we're doing to a payment for labor, material expenses, equipments, any other resources. But all those expenditure is really involved in the business. That's called business cost. What is full cost? Full cost is a combination of the business cost, opportunity cost, and normal profit. So business cost, all of the expenses involved in the business. Opportunity cost refers to whatever the expected returns come out from the best, second best alternatives which have a shortage of resources. But when we talk about the normal profit, it's a necessary, you can say, minimum earnings which a firm must receive to remain in the present occupation. So it's just a nominal earnings where the firm needs everywhere just to remain into a business, to remain to those occupation which have a main interest in. That's called the full cost. Next one is explicit and implicit or imputed cost. So when we talk about the imputed cost, it's a combination of both explicit and implicit. So when we talk about explicit, these are those payments who have no role into a firm. Like for example, in case of supply of the resources, where the wages paid to the labor, the cost of electricity or any rental charges for any plant usage or any other cost of the raw material to the production process. So these are the payments which has been done to the outsiders of the firm, right? Who provide the supply, who provide the resources to the firm. And such payments and such expenditure, such cost is called explicit cost. Implicit costs are those costs which already owned by the firm. For example, instead rather than you or rather than it's good to use the factory by giving up the renting out for a you can say same purpose or to rent it out to another firm. In fact, there is another example that input of an owner and manager to give up the opportunity to earn a salary to at another firm. So instead of being as an owner, being as a manager, you are giving up the opportunity to earn a good amount of salary package at another firm. So these are those costs or using the resources which have the which were owned by the firm, where the no payment is made to outsiders. So if there is a identification mark between the two costs. Explicit cost is the cost you can see or a payment is to be done to the outsider, but implicit costs are those payments which are not to be for outsiders, and that is the main difference between the explicit and the implicit cost. Out of pocket and book cost, when we talk about out of pocket, so definitely the items of the expenditure which involves the cash payments or cash transfer are actually called the out of pocket. So if any other wants to buy a clothing in a very brand showroom, so like for Puma or you can say United Colors, United Benton of Colors, so it's very expensive and it is out of your pocket. So such expenses called wages, rent, and interest. Maintain cost is on involves a provisions to a different assets, provisions for a machinery, provision for any other asset which always need to calculate the profit and loss, and that's called the book cost. Whether it would be any unpaid interest to a owner fund or any unpaid amount of loan where the provision and interest is to be charged, and such costs are called book cost. So that's it for today. We look forward the more and more important part of the this particular theory of cost in the upcoming sessions. So till time, thank you so much for listening, and namaste to all.